So I'm going to talk a little bit about critical values in the rejection region as it concerns our hypothesis test. So we set up a hypothesis test, and we're trying to consider, we've made an assumption, some distribution has a mean, say of mu, and we're taking samples, and how does our sample compare to our assumed mean of mu? We've talked about the idea about the z-scores greater than 2 or less than -2. Those are unusual values. We've gotten to talk about the normal distribution, where we've got 95% of the data within 1.96 standard deviations of the mean. And we're going to use these concepts to talk about hypothesis testing. So if we have a normal distribution, 95% of the data ends up between -1.96 and 1.96 standard deviations from the mean. So those are the z-scores. When I'm doing a hypothesis test, basically what I'm trying to say, when I have a significance level of 0.05, I'm looking at 95% of the data within 1.96 standard deviations of the mean, and then I've got 5% on the outsides. What happens is, if I've made an assumption about a mean, there would be evidence for me to say this assumption isn't good if I had really high values or really low values. So what we're going to do is say, in our normal distribution, 95% of the data is in the middle, and there's 2.5% on each end, in each tail. And that is what we'll call the rejection region. If we take a sample whose z-score is at one end or the other, less than -1.96 or greater than +1.96, that's the rejection region. That is where we would reject our null hypothesis. So for example, I take a sample and I calculate a test statistic, and all a test statistic is really is how many standard deviations away from the mean is that sample. Let's say I get a test statistic of -0.72. So we're doing the two-tailed hypothesis test, where the alternative hypothesis would be mu not equal to something. I calculate a test statistic. I'm 0.72 standard deviations less than the mean, but that value falls within the 95% in the middle. So here we would fail to reject the null hypothesis. If I got a test statistic that's up here, 2.27, that's in the rejection region. Basically, I found a sample that's more than 2 standard deviations away from the mean. This might lead me to believe that this mean of mu isn't such a good assumption. We also have one-tailed tests, either saying mu is less than something or mu is greater than something as our alternative hypothesis. And our rejection region will work this way. If I take a left-tailed test, I have -1.645 as my critical value. Again, I'm taking a significance level of 0.05. In this case, I have all 5%, or all 0.05, in the one tail. That means the critical value of -1.645, anything less than that 5%, that's my rejection region. Okay, so if I calculate a test statistic as I did before, I get -0.72. That one's fine. That seems reasonable. That sample under the assumption of mu. But if I get one that's -2.27 standard deviations away, that lies in my rejection region, and I say, I think my null hypothesis, mu equals such and such, that's not a good assumption. It seems to be that the mean is actually less than what I'm assuming. And then again, the same works for a a right-tailed test. So in a right-tailed test, the z critical value is 1.645. That's the z value that has 5% to the right of it. So again, my significance level is 0.05. All 5% are in the right tail, which is telling me, well, my assumption is that the mean is mu, and if I can get a sample that's more than 1.645 standard deviations away from the mean, that would give me reason to believe that my assumption of mu is not a good one. So guess what number? Negative 0.72. I failed to reject there, but my value of 2.27, that's in my rejection region, meaning the sample was such that the mean was sample mean was more than 2 standard deviations away, or in the case of the critical value 1.645 standard deviations away, and therefore we reject the null hypothesis. But all these rejection regions and critical values, what they mean is this right here, 1.645, that's the value above which I don't want to go, or else I'm rejecting the null hypothesis. Left-tailed below negative 1.645. Two-tailed test 1.96, negative 1.96. The critical values will change depending on whether you're using a z-test or a t-test, and depending on your significance level. But conceptually, the same thing is happening. You've got these tails, and if you end up in these tails, or in these shaded regions, the rejection regions, we're going to reject the null hypothesis and believe that perhaps the mean that we've assumed to be the actual mean, that's not a good assumption.